Okay, so we're talking about systems of equations. We're going to get into, again, two lines, linear systems, and we're also going to talk about linear quadratic systems. Okay, and essentially, I won't make it too difficult just to kind of get the idea across here. So if I had this equation, y equals 3x plus 4, and I had the equation y equals negative 5x plus 4. Right? Those are two different lines that I could graph separately, but the goal of it is that I want to find where these two graphs cross each other. I want to find the spot where, if I were to graph them, where do they overlap? So, again, just kind of do a rough sketch here. Let's say one of the graphs did this, and one of the graphs did this. The spot I'm looking for is the spot where they overlap right there. And that's called my solution. And the solution is going to be an ordered pair, meaning there's an x part and a y part. Okay, and that's going to be the solution. And we can use this. We're eventually going to talk about the speed, the modeling of a speed of either an animal or some type of vehicle. And we want to find out where they would collide, or where would they meet if they started at different speeds and at different distances. So anyway, we want to find that spot where they collide. Now, here is the cool part about this. We can actually solve this system by substitution. And by substitution, meaning normally if I told you y equals 3, oh, I could plug in 3 for y right there, right? Because y equals 3, so I can plug it in. This time, though, y doesn't equal just a number. Notice in the top equation, y equals 3x plus 4. So, now even though that's a more complex expression, we can still plug it in just like we would a normal number. So, I'm going to plug in 3x plus 4 to the bottom equation. Okay, and here's what's going to happen. I'm going to have 3x plus 4 equals negative 5x plus 4. So notice now they're next to each other, set equal to each other, and notice how the y variable is gone. So now I can solve this system because I have gotten rid of two variables, because when I solve I can only use one variable at a time. So I'm solving for x now, which is a good thing. So let's go ahead and do that. I would subtract 4 from both sides. Okay, and then I have 3x over here equals negative 5x. 4 minus 4 is also 0, so I can just leave that. I would add 5x to the other side, plus 5x. And that would give me 8x equals 0. All right, and to get x by itself, we divide by 8. And that would give me x equals 0. Okay, so that's the first part of it. Now I need to find the y part of this. And so what I'm going to do is plug in the 0 for any equation, really. I could plug it in the top or bottom, doesn't matter. So I'll plug it into the bottom one, why not? So that's going to give me y equals negative 5 times 0 plus 4. Notice how the only variable left for me to solve is y, because I've plugged in a number for x, just like what we did for y at the beginning. Okay, so negative 5 times 0 is 0. 0 plus 4 equals 4. So y equals 4, meaning my solution is 0, comma 4. Okay, so and I write the answer as an ordered pair. The x part goes first, y part goes second. So that is how you solve a linear system, and it's really simple when the equations both equal y. A little bit more complicated when it's rearranged, but we can make any problem look like slope-intercept form. Okay, and let's go ahead and talk about another thing you might see. You might see something like this. So one equation might be, let's change colors here. So one equation might be y equals x squared minus 5x plus 7. And then one might be y equals 2x plus 1. Okay, and what you would do is, given that those two, again, notice how both of them are set equal to y. Meaning I could plug in all this, x squared minus 5x plus 7, down into the bottom equation, right? Because if y equals all that, I can plug that in for y in the bottom equation, which would give me x squared minus 5x plus 7 equals 2x plus 1. Okay, and I notice it's quadratic. That's okay, but if it's quadratic, I want to move everything over to the same side, so let's subtract 2x and subtract 1. So subtract 2x, subtract 1. So I have x squared minus 7x plus 6 equals 0. And the reason why I did that is because now I'm trying to solve a quadratic function. Whereas in the example before, they were both linear, so we just used our basic linear solving skills. But now we're solving a quadratic, and there's many different ways to solve it, but Mr. Schwant is going to try x factoring first, where you multiply a times c, which is 6, and then you put negative 7 down here. And two numbers that would multiply to give me positive 6, but add to give me negative 7, I believe that would be negative 1 and negative 6. Because negative times a negative is positive, and then if you add them, it's still negative. Okay, so guess what? The a is 1, so I could take the shortcut here and write x minus 1, x minus 6. Okay, and I'm still trying to figure out what x is, so I'm going to set each one equal to 0. So I have x minus 1 equals 0, and x minus 6 equals 0. Add 1 to both sides, x equals 1. Add 6 to both sides, x equals 6. Okay, so I have two answers for x. And remember, when I'm solving a system, I have to find an x value and a y value. I have to find an ordered pair. But if you think about it, if I were to try to graph these, again, I'll just make a rough sketch over here. I have no idea what these graphs look like, but let's say it looked like this and like this, right? Because one is a quadratic, a parabola, and one is a line. They cross each other 2 times, right? They cross each other here and here, meaning I have 2 different ordered pairs. And notice how I got 2 different answers for x, 1 and 6, but I still need to plug them in to the original equation, so we'll plug it in right here, to find out when x is 1, what's the y value going to be? Okay, so that would be y equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So when x is 1, y is 3. Okay, so that's one of my answers. And then I have to plug in 6. And let's plug in 6 right there. So that's going to give me y equals 2 times 6 plus 1. 2 times 6 is 12, plus 1 is 13. So my other answer is 6, 13. Okay, so those are my 2 answers. And it's as simple as, again, setting the equations equal to each other and then realizing what kind of function you're going to have. In this case, it was quadratic. In the example before, is linear, so we could solve it in 2 different ways. So that's kind of a basic kind of put together there, and that's how we solve systems.